We're going to get started at 3:35, but if anybody has any questions they want to ask right now, since these sessions are so short, I'd be happy to take them while we're waiting. Anything on SQL 2016, SQL Server, whatever, data platform, I'm game. Query Store is awesome. So Query Store is a flight data recorder for SQL Server, and we'll talk a little bit more about how it works and what the architecture is under the hood. But just to give you an example, I have a customer. And I don't work for Microsoft, so I'm an MVP. They were the #2 customer in production on SQL Server 2016. They went live August of last year. And to give you an example of what Query Store can do, we had a really bad query that ran a few weeks ago and took down the availability group because it spiked CPU at like 100% for a while. But we were able to identify that query, because of the availability group failure, we were able to identify using Query Store that, hey, look, between 8:09 and 8:17, this query ran. We were able to grab the execution plan, and we were able to identify the problem with the query in like 10 minutes. I mean, and you could have done that in the past with SQL Server's plan cache if you acted fast enough, because the plan cache is volatile. And you also had to write xquery, which everybody loves to write xquery because xquery sucks. At least I'm a DBA and I think XML is stupid. But now we have JSON, which is hipster XML. So I do like the way JSON is implemented in SQL 2016 a little bit better than I do the way XML is implemented in SQL Server. It's a little bit easier and it's a little bit more flexibility, and hopefully people will do less dumb things. Why? It's not a primary data type, and you can create indexes on it without requiring the data to be in that data type. Because the way you create an index on a JSON column is to create, basically, it's effectively a persistent computed column, sort of. It's like a virtual index. But the thing is, I've had customers in the past where they stuck XML in a varchar max column, and then you can't index it, and you're just screwed. This was a major consulting company that also produces software and is known for their role in the Enron scandal. So also, one thing we'll talk a little bit about that I still hear now, and it's crazy, that people want to wait to Service Pack 1 to roll out a new version of something. Microsoft has been running this code in Azure since like last year. It's not, they didn't release it without any testing or anything like that. It's pretty much very, very, very solid code by the time it hits GA. I know Query Store, for example, has been buried in Azure SQL database for about 3 years and was present for well over a year now. So a lot of the features that came into effect early in 2016 were well tested and executed in SQL DB. Will there be bugs? Yes, there's always bugs. There's bugs in SQL 2014. There's still bugs in SQL 2012. SQL 2016 is probably, of the versions of SQL Server I've worked with, it represents the biggest jump in functionality that I've seen since Microsoft went from 2000 to 2005. It depends on what you're doing. A lot of things are hidden and internal, and we'll talk about a few of those when we get started here. But so there's a lot of things that just go faster because they've rewritten code paths. And then there's also a lot of new features that are really interesting, like Query Store or Stretch Database, if that works for your workloads, or Polybase, or any of the numerous other features. Then a lot of other features just kind of got rewritten. So column store indexes received a great deal of enhancements, as did in-memory OLTP tables. So we have lots and lots of options there. So we have a full crowd. I'm going to go ahead and get started. This is early. I want lots of questions because this is slated to be 20 minutes, but y'all are here. This is Design Seamless Upgrades to SQL Server 2016 with Query Store. I'm Joey D'Antoni. I'm Principal Consultant at Denny Cherry & Associates Consulting. That's me. I'm happy to not be broken at this year's Ignite, because last year I broke my arm about 2 hours before I was supposed to leave. I still presented, which is probably why I'm here presenting again this year. I'm a Microsoft MVP for Data Platform. You can find me at jdanton on Twitter. I blog at joeydantoni.com, and I'm an MCSE for Data Platform and Business Intelligence. But I think those just changed like yesterday, and I'm not sure what my new titles are. So like I was talking about, SQL Server 2016 is awesome. Microsoft really, really loaded it up with features. We have a lot of new functionality. Whether you're a DBA, a developer, a business intelligence reporting person, or even in some places a system administrator, there are just so many cool features, which we'll see on the next slide. As always, though, upgrades can be scary. Weird things can happen. Your code can stop working. Your code can start going slow. Your clients can stop connecting. Some of those things we just need to test. So like your client stops working, you need to test that. Others, like your code going slow, that's where we're going to talk about query store. So we're going to talk about kind of a methodology and an approach for doing upgrades and taking advantage of some of the functionality that's built into the query store in order to do an upgrade rather seamlessly. So some of the new features in SQL Server 2016, and I'm not going to go through all these in detail, we'd be here for 3 days, but I'm going to hit on a few of them. Always on availability groups. Yeah, this feature has been in SQL Server since 2012. What changed? Basically, Microsoft rewrote the entire internal log transport stream and redo apply mechanism. So without getting into too many boring technical details, it just goes faster. They changed a lot of the code paths. They simplified things. You'll get more throughput. One of the things is they don't use compression if you're using synchronous replicas. So if your replicas are next to each other, there's no need to take that penalty to compress the data. So you get an overall faster stream. You can turn it back on using a trace flag, but by default, it's not there. Polybase is a really cool feature. I look at this feature 2 ways. Polybase can connect SQL Server to Hadoop. That is one approach. So if you're in a shop that's doing big data and you need to talk to relational data sources, you can easily talk back and forth to your data that's living in a Hadoop distributed file system using SQL Server 2016 Polybase. The other component to this that I'm doing a project on right now with a client, and it's going to tie into another feature that I'm going to talk about. If you control your own code, you can use this as kind of an archiving feature because you can write data out to Azure Blob Storage. And in doing so, you create this concept that's known as an external table. If anybody's worked with that other database that's out in California, they've had this concept for a while. But in our case, we're not storing it on a local file system. We're storing it secured in Azure Blob Storage. The other end of that, if you don't control your own code, is a feature called Stretch Database. And this is a feature that leverages Azure SQL Database. And it takes rows from your on-prem tables and brings them to the cloud. And people are always going to ask, isn't that going to be slow? Yes, it is going to be slower than your on-prem database. It is stored on premium storage, so your latency on the secondary is not fast, but you're in the remote server is not going to be fast or will be fast, excuse me. Storage is fast, but network can be slow. So what happens with Stretch Database is you issue a query, the optimizer says, hey, some set of rows is in the cloud. It sends that query to the cloud. That query gets executed in the cloud and returns the result. So you're not actually relying on execution on-prem that's going to the cloud. Stretch Database is very cool, but it's designed for archive workloads. So one of the things you should really monitor if you use that feature is how often you're hitting the stretch part of your tables. And if you're hitting them too frequently, you might want to evaluate bringing that data back on-prem. But overall, a really cool feature, because as much as people like to say storage is cheap, storage is expensive. I used to work at a big cable company, and I bought a lot of storage. And let me tell you, that stuff that EMC sells you, not cheap. Our services, another kind of interesting feature. Not a lot of folks in the DBA and system admin space are 100% up to speed on this. But R is a statistical modeling language that if you work at a company that has data scientists, also known as statisticians, If you have those guys or girls, you may be using this. One of my early 2016 customers using this for some things. And basically, if you've ever run the CLR in SQL Server, so where you which is CLR is Common Language Runtime. If you can run like a C# code assembly within SQL Server, it's a little similar to that, except that we explicitly run the code. So the code image runs like dynamic SQL. But we create what's known as an external procedure that's going to run our code. Column store, if you're not familiar with column store index, this is a really fantastic feature that's kind of really changed the way we architect data warehouses. Data is stored in columns instead of rows. And the cool thing about that is when you query a column store, it only returns the columns you need. The column store is your only index. This is cool because you don't have to worry on a really wide table about how do I index it properly for what workload. You just put a column store on it. Not good for OLTP workloads. For OLTP workloads, we have in-memory analytics. This feature came out in 2014, had a lot of limitations. There were a whole bunch of things we couldn't do. 2016, everything is a lot better. It's mostly feature compatible with SQL Server regular tables. We can do a lot of things. We can also use what's known as natively compiled stored procedures. And those are stored procedures that are gonna execute as C code, so they'll execute much faster with many fewer CPU calls. Temporal tables, another really nifty feature. This allows us to configure a table, and the term in SQL Server is system version tables, and it keeps a version of the data based on time. If anybody has ever worked with a data warehouse where you've worked with something like a type 2 slowly changing dimension, this can kind of build that sort of functionality in automatically. In some places, you might still want to use traditional type 2 SCDs, but temporal is easy and it's fast. You can do all sorts of cool things like store your history tables on a different file group, store on a different disk device, compress them slightly differently. My aforementioned JSON support, every other database did it, so Microsoft had to. No, seriously, JavaScript is kind of taking over the world, especially if you work in Azure space and you build ARM templates. You'll know you kind of have to know JSON. So that's there. It's not too complex, but there's some really cool functionality. And for the most part, in my testing with that feature, it worked really well. We also have a feature called Always Encrypted. Encryption has traditionally been hard, and another problem in shops that had big separation of duties requirements was that the DBAs always had access to the data. This was a bit of a problem. With Always Encrypted, the data is always stored encrypted in the database. So the data is never unencrypted, only gets unencrypted at the app layer. The app holds a master key to unencrypt. Cool feature, only problem, it's enterprise only. Boo. On the other hand, row-level security, and by the way, of everything I talked about so far, Always On's now in Standard Edition. Polybase has some functionality in Standard Edition. Stretch is in Standard. R services in Standard. Temporal's in Standard. JSON's in Standard. Row-level security is in Standard. Column store and in-memory are enterprise only. But row-level security is kind of exactly what it sounds like. It's row-level security. So you configure a function, and based on that function, it will limit what users can see what rows. TempDB, if you don't know this, on your older instances of SQL Server, you should have one TempDB file per number of cores you have, up to about 8. And then you should add more as needed. This isn't an I/O issue, but it relieves page contention that's in memory, so it's almost latch contention for two very specific types of pages in SQL Server. You used to have to configure the files yourself. I had some code that would do it automatically to go grab the number of cores and then configure the files. There were also two trace flags. If you're not familiar with a trace flag, it's a special way to tell SQL Server to go do something interesting, some different behavior than default that were associated with TempDB. Those are all built into TempDB now. So TempDB works the way every consultant said it should have worked years ago. Then finally, we have a modern BI platform. Reporting services no longer looks like it was built in the late 90s next to Crystal Reports. It's really pretty. It's got a mobile component. That mobile component is enterprise, but And we also have tight integration with Power BI. So from a BI perspective, everything is really, really nice now. And a lot of this came from in-house development, and a couple of these things like the BI platform came from an acquisition of DataZen. Part of the R services came from the acquisition of a company called Revolution Analytics. So lots of interesting things coming together. I mentioned this before, but I like to mention it again. Don't wait for Service Pack 1. Please don't. Service Pack, the biggest reason is Service Packs don't come out as quickly as they used to. Microsoft has moved to this more everything, if you can't tell at Microsoft, has changed and moves faster. So we get cumulative updates now. Cumulative updates, we're already on cumulative update 2 for SQL Server 2016. That's what I'm going to be running in the demo here. It came out last Wednesday or Thursday. GA was around June 1st. So in 3 months, we've had 2 CUs. That's generally about the cadence. It's about every other month. A little more at startup, obviously, just because there's a few more bugs to catch. But Service Pack 1, I can't tell you when it's going to be out, and it's going to be a while. Cumulative updates have the same level of testing. You want to get into that habit of including those, because one of the things Microsoft used to do in the past was they'd only include new functionality in a service pack. Now, new functionality gets included in cumulative updates. It was a big deal when it happened the first time. I think it was in 2012 they added the ability to back up to Azure. Now, it happens quite frequently. So if you're not applying those CUs and you're lagging behind, you're missing out on a lot of cool features. Microsoft is not the same company it was. You may have noticed the CEO changed and a lot of things changed, mostly for the better as far as I can tell. I'm not an employee, but I work with the product team a lot, and I see a lot more dynamic. I see a lot more good engineering. I see less stack ranking. I also see a company that's using the cloud to help build better products. So like I mentioned a little bit earlier when we were talking, a lot of this code has been running in production in Azure SQL database for well over a year now. And the cool thing about Microsoft having Azure SQL database is really twofold. I see 2 huge benefits. The first is they actually have to run operations now. So they hear all the problems we've been complaining about for the last, 20 years. And they actually have to deal with those problems. So I've seen a lot of things, like a good example is that TempDB thing. That wasn't a lot of code to write. I know 10 consultants who have various scripts to do the same thing. But they built that in, so more people will have better configurations. In their place, it's probably easier to automate deployments and such. So that was my first point. The second is they just have a whole bunch of test data, right? So before, to give you an example, the early release program usually has 20, 30 customers in it. So that's 20 to 30 customers that might not be using all of the components of the product. And that's their test bed. So that's what they're rolling out in prod. Now, with Azure SQL Database, they roll out that code, and they have, the last number I saw was like 4 million databases. So most of the internal Microsoft applications, plus a whole lot of customer applications, get that new code. And those code changes roll out in a phased manner to Azure SQL Database, but they do roll well ahead of where you'd roll out on-prem. They do a monthly push of code. There are some features that are private preview and then public preview. But when they go GA, and you have them whether or not you want to use them. So what that means is development happens fast. Those Azure fixes can happen pretty quickly when you're doing a monthly build and release like that. So lots of cool stuff. So what are the risks of upgrading? SQL Server v new is buggy. Common thing. SQL Server cumulative updates are not tested. We talked about that. No one has used this code in production. And then finally, the last thing, and I need to fix that last bullet there, the queries suddenly get slow. So we've kind of addressed SQL Server v new as buggy. Lots of people have been using it for lots of time. Yes, there were bugs in development. No, they were all mostly, they're still there in GA, a few. Those cumulative updates fix stuff, but it's no more or less buggy than any other version of the software you're going to be using. The cumulative updates used to not have the same test path as service packs. Now they do. The old one was nobody had to use this code in production, and companies didn't want to be on the bleeding edge of technology. I remember having a really horrible manager who always wanted to say, no, we never want to be on the bleeding edge. Let's run 2 versions behind. Bad idea. Lots of people using this code in production. Finally, the last risk, and probably the biggest risk of any database engine upgrade, no matter what database engine you're using, is that your queries suddenly get slow. And the reason for this is that the database optimizer changes between versions. There's a pretty big change in optimizer behavior between SQL Server 2012 and 2014. A part of the code, known as the cardinality estimator, changed fairly significantly. And while this cardinality estimator helped 90% of the queries based on Microsoft research, there is a certain percentage of the queries that were negatively affected upon upgrading to 2014. And there were some ways around that. You could turn on some trace flags, you could alter behavior. But it's problematic and it's a bad user experience. So let's talk about the query store first. This is really, I'm no longer a full-time DBA, though I still do a lot of DBA work. This is probably the best DBA feature I've ever seen. Oracle has some features that are similar, but you have to pay for them. This is included in every edition of SQL Server. So big win here. I like to call it a flight data recorder for SQL Server. So you have to turn it on, that's one thing. And it's not enabled by default in model. So we'll walk through turning that on when we get to the demo in a couple of slides. But it's going to capture all your largest queries. You can sort them by a number of things. It's also going to maintain a history. One common question I get when talking about this is, what's the penalty? Like, how much performance does this take? And roughly in talking to the product team, it's 1% to 2%, so nothing too huge. I certainly haven't noticed it, and I've gotten way more benefit out of having it than not. So a couple of things it stores in its schema. It keeps a query plan history, and it keeps runtime statistics about the query. And it keeps a history of those runtime statistics. So this lets it identify regress queries. And what a regress query is basically if a query was taking 5 milliseconds to run historically, and suddenly it starts taking 35 seconds, SQL Server's query store feature is going to identify that query and mark it as regressed. And you can then evaluate and tune it. I say my favorite, pretty much my favorite feature. So let's talk about the upgrade process before we go into a demo. So here's the safe way to upgrade. And this assumes you're running on an older version of SQL Server. So whether you're going from 2012 or 2014 or even 08 R2, upgrade to 2016. Maintain the compatibility level of your database. So each database has a compatibility level that's associated with it. This changes a bunch of things. This changes optimizer behavior. This changes some code paths that you can use. Not generally a good best practice to stay on that older compatibility level if you can help it. So then what you do is gather your query store data for some period of time. So you want to run for a while, understand the performance profile of your server and your queries, like your query store capture data. Then when you feel comfortable, then you upgrade the database to compatibility level 130. There's a bunch of benefits in doing that. We'll talk about them in a later slide. But once you do that, then you can identify regress queries. What we can do is when you identify a regress query, because the execution plan changed, since you're running in that older compatibility level, you'll have that older execution plan in the query store. One of the best features of the query store is that you can force an execution plan. So you can say, I want to run this execution plan for this query. That gets honored across reboots, that gets honored across database server moves, persistent force plans. Did anybody ever use force plan hints? A few of you survived. Did they ever work? No, yeah, force plan hints were terrible. There is a way you can hint things. Generally speaking, if I'm trying to have to do something like that, I'd rather just hint an index. But so let's take a look at the query store. Let me switch modes here. So here we have a database, and I want to show. Let me go ahead and create a new database so I can show you the process of enabling. One other thing Microsoft changed, they got rid of the horrific file limits, the file sizes of 2 meg and 1 meg. They bumped it to 8. So we've moved into the 90s. A couple of things here. So so I just clicked on database properties for this new database I created, and I'm in the query store. By default, this is off. One thing I've been doing on my customer servers is turning it on in model. Because if you're not familiar, the model database becomes a template for all databases that are created after. So if you turn it on in model, it will get inherited by all new databases that are created on that server. The one downside to that is there's no GUI like this in model. I've asked the product team, I haven't heard back. And I've lost my mouse here. Hang on. So here, our operation mode by default is off. We have two options here. We have read only and read write. Read only on our query store is pretty useless for us. The only time we'd ever use that is if we had a set of plans we wanted to maintain. I'm not even sure. But usually the only time I see this in read write is or read only is when it goes to when I'm having a problem. Because if your query store fills up, it will go to read only. So I'm going to choose read write here, and I hit F1. Here we have our statistics collection interval, so we can change our granularity to see when statistics are collected. That's not normally something I change. I think I do in the demo database here. I do change the max size to a gig. 100 megabytes I found was too small. I know I complained about storage being expensive earlier, but I can usually give up a gig to have performance data. The one downside to this is it does live in your primary file group. So there's no way to move this onto another volume. So let's go ahead and click OK. And then here I have a nice little console app. And I'm going to run a couple of workloads. Let me launch this again and run the other workload. And while this runs and collects some data, does anyone have any questions right now?
I have a question.
Yeah.
What do you recommend the best way to upgrade?
The question. Yeah, the question was, what do I recommend is the best way to upgrade? It depends. I hate to give the consultant answer. If you have new hardware available or a new VM, it's always pretty easy to do a new clean install. That said, I've done a bunch of in-place upgrades. So my customer that went live last August, they were in the TAP program, which meant they had a new build every month that we had to upgrade. So I've probably done, they had an availability group, so I've probably done 20 in-place upgrades on that box, and I haven't had any issues. One of the things that Microsoft did with SQL 2016, which was one of my problems before doing in-place upgrades, is the tools are now separate. So SQL Server Management Studio and SQL Server Data Tools are separate installs from SQL Server. And so you don't get that weird overlapping menus. You still get some overlapping stuff, but the only downside to in-place upgrades is there's no failback if you do it that way. But if you don't have the hardware, you don't have the VMs, you don't have the VMs. So I don't have any inherent problem with doing it in place. All right, let's take a look at our query store now. So the first thing we're going to look at is our top resource consuming queries, and we have one. This is a pretty simple test, but I just want to show you a couple of the things we can do here. So we can sort this on CPU time, duration, execution count, my favorite, logical reads. Bless you. We can also sort on memory consumption or physical reads. I typically go straight to logical reads. Occasionally I'll get a CPU time. Here we have the plan summary for this query. In this case, we have 2 execution plans, and we see that it ran pretty good with plan 23, but it didn't run so well with plan 1121. We'll get back to that later. We also quickly can see whatever that execution plan is. Now, for the real magic, I want to compare these two plans. Well, let me show you one other thing first. Here's where we can configure this. So we can configure the resource consumption criteria based on all that stuff we saw. But here we can configure the time, and we can configure which mathematical function we want to capture that based on. So if we just want to see the max, or we want to see the highest average for things that are running a lot. And then this time interval thing is what I was talking about with how you can quickly identify, hey, something ran crappy over the weekend. Let's see how we can fix it. Yeah, go ahead. Excuse me? Give me 1 second. So here we have this query. We have one run of it that was really good and one run of it that was really bad. If I can find my mouse. So I can select both these plans by clicking Shift. And then I have this really cool button called Compare. And it's going to show me the execution plan for those two runs, those two different queries. It's also going to show me, and I don't want to go too much into internals. If you're a real geek about SQL Server, you'll know what some of this stuff is. But it's going to show us why we chose those plans, why the optimizer chose those plans. So here in my bad plan, it did a full table scan. So let me hide this properties. So if I look at that operator, it did a table scan, lots of I/O cost. My other plan did an index seek. An index seek is when SQL Server goes out and grabs the single record it went. We could probably make this better. This did an RID lookup. We have other options, but clearly plan 1121 is better, even though it has that one outlier run. So what I can do here usually is click Force Plan and run that plan. I don't know why that's not working for me. I did just install a new build of Management Studio. Never do that before a demo. But using that force plan, and you can do this in T-SQL or you can do it through the GUI, you can force SQL Server to honor that execution plan. So benefits of combat level 130. So this means getting your databases fully compatible with SQL Server 2016. The insert, if you're using an insert select statement, is now multi-threaded, which is a pretty big improvement. So that can have a parallel execution plan. Parallel inserts are always a good thing. Likewise, queries on memory optimized tables can now have parallel plans. The SQL Server cardinality estimator got smarter. I was actually working with the query store team to try to identify some queries that would go backwards in incompatibility level 130, so I could demo what I talked about earlier. And I'm not making this up. Borko, who is doing another talk on query store, said I really couldn't identify any queries that we could get to slow down in 130 because they fixed most of the regression problems that they introduced in 2014. So the optimizer is just a lot smarter. There are big improvements for column store indexes. The column store improvement indexes would be about 3 slides, and I have just a couple minutes left. And then finally, there's some improvements into how statistics are gathered, and especially in larger tables. So the threshold for gathering statistics has changed. So in summary, SQL Server 2016 is awesome. Really cool release. Query Store makes your upgrades easier. It makes life as a DBA easier. It's so awesome to be able to go in and say, hey, who ran this? Especially when you catch that one big outlier query. Or just to go back to the devs and say, hey, you might want to change this code, or let's talk about an index here. Those sorts of things are really, really handy Just being able to identify the biggest load queries running on a server. And then finally, compat level 130 has really big improvements. It is worth it to get there if you do your upgrade, so don't stay back on an older compatibility level. Please submit session feedback, and I can take questions. We have about 5 minutes left. Any questions?
So do you always leave query store on?
Yes, I always leave query store on. It's got a flush mechanism, so it's not going to grow beyond that size. You may need to adjust the size depending on how much data you want to keep. I think one of the suggested enhancements in Connect is to be able to move it off of the primary file group, because it would be nice to be able to just throw it onto like a cheap non-SSD disk and run that way. But yeah, the data is worth it to me to keep it always running. Yeah.
So is the idea behind running it in the older mode, in the newer mode, to be able to look and see where it ran better in the older and force it to use that in the newer?
Yeah, the question was, is the idea behind running in the older compatibility mode to show what ran better in the older mode and then fix it in the newer? Yeah, that's exactly it. So anything that goes back, there's a regress query tab, or report rather. I don't think we have anything that's going to regress, but we can look. Yeah, we don't have anything that regressed, but there is this report there that regressed. So when you turn that on, you look for things that regressed, and then evaluate forcing plans. Yeah, yeah, I'll get you in a second.
Is there a way that if you wanted to try this in an old knowledge environment with the exact same database, you could migrate that information forward to the production environment?
That's a good question. The question was, is there a way, if you did this in dev, could you migrate your query store data only, I'm presuming, to a production environment? Find Borko at the SQL Server booth. If not, I'll find him, or find me at the SQL Server booth, and I'll get an answer to that. Theoretically, yes, but they're system views. So, like, there's a hack way you can update system views that I probably shouldn't even talk about. That's a really good question. I'll follow up. Come get my card after. I'll follow up with Borko. Yeah. Yeah.
I would like to know why query created. So what has been changed in the week? Is it possible? And then we see more statistics out of date or change data, whatever.
Yeah, I mean, so really, the way you do that, and to go back to that plan comparison, if we look in this properties tab here, so what you're asking is pretty complex. It's doable, but we want to look at things like,
My users call me and they suddenly say, my
Yeah.
database is slow.
99 times out of 100, that's your statistics being out of date. A lot of people think rebuilding indexes fixes that. One of the things that rebuilding indexes does a full update of your statistics. So typically that's a statistics issue. Sometimes it is an index fragmentation issue. Sometimes the more rare scenario is you run into a situation where you're mostly living in your cache, and then your data grows beyond the size of what your cache is, and you start hitting disk. And so that's generally evidenced by like a much higher number of physical reads and a greatly increased I/O latency from your baseline. So that's where it's important to kind of have baseline infrastructure information, like what's your typical read and write second per disk, so you can get an idea of how, or read. Yeah, that's the perf mine counter. So you can get an idea of what your server is running like on a normal basis. If anything changed server-wise, or whether it was something in the optimizer where you got more rows, your statistics got out of date. You can figure some of that out just by looking at the execution plans. Some of it you just have to do a little bit of forensic digging.
Yeah, but I thought it doesn't randomly change the execution.
Well, the execution,
Why did it change it?
there's a lot of things that can change execution plans though, because your execution plans can get forced out of cache if you come under memory pressure. You can have parameter sniffing where you had an execution plan that ran well for one set of parameters and bad for another. statistics updates would cause a plan flush. Also, there are certain parameters that if you change, like max degree of parallelism or cost threshold for parallelism, your your cache would get flushed. So there's a number of things that could cause that your execution plans to get changed. Yeah, yeah.
You said that the queries don't flush out back there. Are they system DMVs or they got flushed with restart?
They won't. No, they won't flush with a restart.
Okay, so does it just roll over when it hits max size?
Yeah. There's an algorithm you can read about it on. Yeah. It's not rocket surgery. It's like I think first in last at. Yeah.
I just want to make sure we're going to go away with a restart.
No, it's persistent across trees. Yeah, because it works on Azure and they restart stuff without you knowing it all the time.
Now, what's really,
Excuse me?
what's really,
Well, so you can look. There's a few system views that are associated with it. There's an ebook that I wrote for Microsoft called, I think, Introducing SQL Server 2016. It's free. I have a diagram of all these, ERD of all these views that shows the relationships.
I'm not talking about really the table stuff. I'm talking about what do we really store? What kind of information?
Just statistics about execution history, and then execution plans that are associated with them.
So, what happens, say, if you have a query which is parameterized,
Yeah.
so depending on the value of the parameter, it could have different plans.
Yeah, and that's where you can you have to go in and kind of investigate what the parameters were. I forget if the parameters get stored or you have to capture them through Profiler or extended events. I'm not 100% sure on that. It does show my parameter list, but it just shows them as variables here. Let me see if I have anything else under there. Oh yeah, it does capture parameters. So, I thought so. There I have my parameters. So here this ran with a value of 105. Does anyone have any other questions? Yeah.
Is there any slowdown running this on a gigantic database that's 2 terabytes of
You describe my customer, and we haven't noticed. Yeah. I mean, they're on pretty. So they're on beefy servers, memory and I/O-wise. Like they have solid state and 768 gig. They only have 8 cores, so they are CPU sensitive. SQL Server is expensive. It's still way cheaper than Oracle, but it's still expensive. They're about to have to upgrade, and they're not happy about it. Like the licensing is going to be way more than the server. But yeah, they say it's a 1 to 2% impact. Honestly, this customer though, they have so many other benefits from things like column store. I think any slowdown they wouldn't have noticed. Yeah. Cool. Well, I got to run. Thanks everyone. I hope you enjoyed that. Hey. Yeah, no problem.
Actually, I have 2, but if you're in a rush.